또 이상으로 달리는 진공자기부상열차에 대한 것입니다. 이 분야 세계적인 성자인 데릴오스터 ET3 글로벌 얼라이언스 창업자로부터 글로벌 하이퍼루프인의 이슈 성과 전망으로 강의를 듣겠습니다. 데릴오스터님은 지금 미국 덴버에 계십니다. 지금 화상으로 연결되어 있습니다. 만나보시겠습니다. 박수 부탁드립니다. Thank you very much. Please deliver your speech.
Transportation. Thank you very much for inviting me to speak at your important conference. I think Korea is a keystone for the development of ET3. Transportation is the master key to survival. Every quantum transportation advance doubles the global standard of living. Steam-powered boats and trains displaced muscle power in the 1800s due to market value. They offered far more benefits at far less cost. Cars and aircraft displaced trains in the 1900s because they offered more benefits for less cost. In 1956, a 5 megabyte hard drive weighed a ton. And now we have a micro SD card the size of my little fingernail, only weighs a half a gram, that will hold 1 terabyte of data. That's 400 billion times more data density in 65 years of time. The leaders who leverage the computing and networking advances are producing sustainable world-class economies for their nations by doing so. Mobility advances offer much, much greater gains than the past advances. The question is how to get it done. So ET3 Global Alliance is a team of 400 licensees that are driving the next quantum leap in transportation in 27 nations. What is needed now are visionary government leaders willing to commit to changing the world for the betterment of humankind. There are many reasons that cars and roads have won the global transportation market. Personal comfort is a very big part of the automobile's success. A train, there's also the big vehicle is a potential disease vector that has been exposed in recent times. The global CV-19 pandemic scare is helping to expose the big risks of transporting large groups of strangers in close contact and on a global basis. If it weren't for the aircraft shutting down on a global basis, the virus would have spread at a much faster rate. So, in considering a next future quantum leap in transportation, we must make it a lot safer than the present modes are offering. Smaller vehicles and traceability is one way to make that occur. One reason cars displace trains is the use of full-speed passive interchange design philosophy. Unlike a train on a track that must go through a physical switch, on a freeway, an automobile controls the diversion instead of the track controlling the diversion. So train frequency is limited by the actuation time of a mechanical switch, whereas automobile on a freeway, the frequency of vehicles is only limited by human limits of judging the vehicle spacing and timing. And with automation, that can be greatly improved. And we are on the verge of the automation in transportation. There's another thing to consider first, that observing the perpetual motion of the heavens is the foundation of science. Earth has been orbiting the sun at 100,000 kilometers per hour, and the Milky Way orbits the sun orbits the Milky Way at 320,000 kilometers per hour. So the average person travels over 500 billion kilometers during a 70-year life on spaceship Earth without burning a drop of gasoline. So what we're doing at ET3 is we are bringing the next quantum leap in transportation to reality through
The future of transport luckily looks very different than today. Implementation of new technologies no longer require the fast burning of fossil fuel to get you to your desired destinations. With future transport, you can get there a lot faster and cheaper. Imagine a world without pollution and noise from traffic. This world is brought to you by the fifth mode of transport called Evacuated Tube Travel Technology, or ET3 in short. ET3 is poised to reach speeds of, yes, 6,500 kilometers per hour. In the coming decades, an access portal will be built near to you and connect you with shopping malls, supermarkets, towns, beaches, and tourist destinations all over the planet in one go. No more transfers. On the left, you see the tube with uninterrupted traffic flowing at the design speed continuously and without fossil fuel. This is the ET3 frictionless limousine that floats on magnetic levitation. Magnetic levitation, or maglev in short, truly is the technology of the future and has already been used for decades effectively and safe. Entering the evacuated tube system that allows for frictionless travel happens through an airlock.
I am expert in this basic fields to evacuated transport technology for already 40 years. It is feasible technology. It is possible to do. The only thing that is required is that some decision makers will say, yes, I believe in this technology, let's do it. Let's dare, let's take a chance, and let's do it.
This then turns into the world's largest infrastructure project, feasibly a 50-year build-out, maybe even longer, employing hundreds of millions of people. I feel that this becomes a fundamental piece of our future.
In another presentation, Dr. Fry, who you just saw, he is a world-renowned futurist. And on futurespeaker.com, Dr. Fry shows that global mega projects are on an upswing. Right now, they're mostly led by China instead of the United States. And this map here shows several global transportation projects that have been proposed for many years and are likely to continue on. Korea is at the center of an ET3 connected world. Most of us would rather ride in a car than a bus. When we look around us, we can plainly see that automobiles have won the global transportation market. Cars have won because they offer the most value for the most people. ET3's philosophy is to maximize transportation value to win the global market share in the long run for one global system that can connect the entire world at speeds much faster than jets. Right here you see that the ET3 capsule, which only weighs 180 kilograms empty, hauls as much as a 2-ton car or SUV. The ET3 high-speed infrastructure uses 1/35 of the amount of concrete and steel compared to the high-speed magnetic levitation rail infrastructure that you see on the extreme left of the screen. ET3 can also accomplish 50 times more transportation per kilowatt hour and a 50 times labor savings through automation, as has already been proven in telecommunications. We currently ship more goods through pipelines than all other forms of ground transportation, claims Dr. Fry. So why not people and freight as well? What you see here is the fact that at a 650 mile an hour, 650 kilometer per hour design speed, the two-tube ET3 system has greater capacity than 40 lanes of freeway traffic, 20 lanes in each direction. It has 10 times the capacity. And if we increase the speed to 6,500 kilometers per hour for a global system, it would have 100 times the capacity of a 4-lane freeway. A quarter the cost, yet 10 times the capacity. Similar to the way fiber optic lines are used instead of human switched copper wires of old. And ET3 is attracting world-class competition. Elon Musk announced his hyperloop idea in the spring of 2012. That was a couple of weeks after licensees in California sent info packs about ET3. In our meeting with Elon, it led us to believe that hyperloop is designed to support the market for cars instead of challenging cars' dominance as ET3 has the potential to do. With the hyperloop, you can drive a car right into the capsule, but the small vehicle has many advantages. Let's compare hyperloop with ET3 on a more detailed basis. If you see the ET3 infrastructure in green, you can tell right away that the reduction in mass of the vehicle results in a reduction of materials required to build the infrastructure. The tube material demands scale with the diameter squared. So if we double the diameter, it takes 4 times more material costs and increased construction costs for mega machinery. For the hyperloop infrastructure to be big enough to move shipping containers like they are claiming, it would require a tube diameter 3 times greater. If you square that, it's 9 times more material and around 10 times or maybe even 15 times more cost, because the cost of the infrastructure to build the infrastructure goes with the cube of the scale factor. Here we can compare some of the design parameters of ET3. The table here that I'm presenting shows many advantages of using optimal size vehicles that people prefer to ride in. People prefer to ride in a limousine or a taxi compared to a bus. And with the added cost of building the infrastructure and the slower speeds of the hyperloop, ET3 offers much more benefits for much less cost. We can secure our borders and move food and water and other cargo around the world with much greater speed and much more efficiency. Fruit and vegetables from Korea could be sent to the United States fresh in 4 hours or less lead time. Or cargo could be sent to Europe in an equal amount of time. A 2 or 3 hour lead time for getting a pallet delivered directly to the store from the manufacturer, literally connecting the entire world. Also, ET3 offers secure, non-permeable infrastructure from origin to destination. And this yields a 100-fold improvement in the ability to track movements of cargo and persons of interest, or to track disease vectors that might have been released onto the public through a new virus like COVID-19. With ET3, the vehicle size of only 4, 5, or 6 passengers, like a car-sized vehicle, with family-sized units, will spread diseases at a much lower rate. Also, in addition to less terror risk, ET3 addresses the major causes of transportation-related death, which is failure to control the vehicle and failure to control the right way of travel and travel conditions. The first ET3 project, we believe, could be built very adequately in Korea. And we are looking to build an ET3 demonstration project. If it's operated as a world-class attraction, it can recover its $25 million cost in a few years of operation if it's built in the correct location. And we do believe that Korea constitutes the best location right now. There are millions of kilometers of right-of-way in the world. There are thousands of kilometers of railway systems in Korea, and at least some of that right-of-way could be used to meet ET3 needs without disrupting its original use. In fact, ET3 could be built right along highway alignments, freeway alignments off to the side, or right down the center of the median between the lanes. And with minimal disruption, with automated production capacity that exists all over the world to build it. Any location where the traffic is great enough that a 4-lane capacity highway, 2 lanes in each direction, is running out of capacity and needs to be upgraded to 3 lanes in each direction, is a location where ET3 can very quickly recover its building cost based on a equivalent cost of driving a car or flying in an airplane. With a round-trip capacity of only 120 passengers per hour, the demonstration project would only take about 3 years to recover its cost if operated as an amusement park. We believe the best location for ET3 right now is in Korea, and that with a looking ahead, we can see here on the screen a global transportation system that would operate at 6,500 kilometers per hour with underwater connections to China and underwater connections to Japan, could put Korea at the global center of transportation. Of course, we would like to use local products and local services and local production capacities to build everything. Korea has a lot of steel capacity and tunneling capacity that has been perfected with your high-speed rail system. So with that said, that concludes the presentation. Are there any questions?
Hello, David.
Yes?
This is Tiger.
Hello.
Hello. Nice to meet you.
It's a pleasure to meet you.
I have one question. ET3 구상이 실현되면 서울 뉴욕을 약 20분을 2시간 정도에 주파하는 인터컨티넨탈 트랜스포테이션이 만들어질 걸로 되어집니다. 근데 아무래도 우려되는 것은 세이프티, 안전성 문제로 생각이 듭니다. 만약에 열차가 가다가 고장이 나서 정차를 한다든가 또는 실내가 감압이 된다든가 또는 일식 공포증이 있는 사람들은 탑승을 하지 말아야 되겠죠. 그리고 갑자기 심장이 무거워지면서 급하게 화장실을 가야 될 경우에는 어떻게 해야 되는지.
Very good question. Daryl?
Yeah, sure. First off, ET3 is very different than a train. It's much more like an automated car on an automated freeway. And the passengers in the vehicle make requests of the system. They're not in direct control, but they guide the vehicle, and the vehicle goes where they want it to, anywhere in the network, just like an automated car on an automated freeway. So if the passengers need to, if they have an emergency, like they need to use the restroom or something, if they can only maybe 5 or 10 minutes, the next access portal will be available, and they can make indication that they want to stop at the next available exit, just like a car on a freeway. Of course, just like a car on a freeway can handle emergency functions if necessary with plastic bags on the vehicle and stuff like that. That is possible. But just like the automobile does not need to bring a toilet around with it, ET3 will not need to bring toilets on the vehicle. It will be much more like a car on a freeway. Also, you brought up the safety issue of traveling at the high speeds. ET3 is automated, which removes a lot of the risk associated with transportation, because most transportation now is human controlled. And it's already been proven that people are not nearly as good as computers and automation at doing repetitive tasks over and over and over and perfectly every time. Can you imagine if our cell phones were operated with human switchboard operators? How many dropped calls would we have? Also, ET3 uses magnetic levitation, and it has no moving parts and no mechanical engines with thousands of moving parts like a complex aircraft. So mechanical failure is reduced by maybe less than 1/100th of the possibility for mechanical failure. Also, the right-of-way travel is protected. Nothing can get in the way of the vehicle, not even air, or the vehicle cannot leave the path of travel. Once the vehicle starts out, it's coasting the entire trip, and if there's nothing to slow it down, it will not. If there is an emergency and something happens to the guideway, all of the vehicles can be brought to a safe stop by flooding the entire tube with air. Remember, the tube has no air in it. It's like space travel conditions inside the tube. So it's literally like space travel on Earth. But if air is admitted to the tube along the entire length at the same time, the air going in through apertures that are sized and spaced such that the inrush of air slows the vehicles down aerodynamically. It also acts like a big airbag between the vehicles to absorb any impact potential for collision avoidance and stopping any potential collisions between the vehicle. So a lot of these items and safety things have been worked out and calculated to the point where it's easy to show that ET3 will be approximately 1/30th of the relative risk of a high-speed rail or aircraft. And of course, we know that aircraft and high-speed rail is about 1/15th of the relative risk of driving in a car. And of course, driving in a car is an entirely acceptable risk for most of us on a daily basis. Great questions, Tiger. Thank you.
Thank you very much. 시간 때문에 마무리해야겠습니다. Thank you for joining us. I hope to see you again.
Good. Very good. Excellent, Daryl. Excellent. Good.
네. 다음 강의는 어떤